Hello, this is Mrs. Taylor, and I'm going to walk you through how to determine certain characteristics of a quadratic function given an equation in vertex form. The previous video was an equation in standard form, so it's going to be a little bit different. We're going to find the same things using the same set of directions from your study guide, and we're going to use problem number 5 to go through all of this. But the process is just going to be slightly different because our equation is in a different form. So the first thing I'm going to find instead of the axis of symmetry is the vertex, because vertex form is called vertex form because the vertex is right there. It's the 3 and the 1. And remember, in vertex form, it's opposite of what's in the parentheses. So if it's minus 3 in the parentheses for my vertex, it will be positive 3. And the k value is just whatever it is. And the reason why I did vertex first instead of axis of symmetry is because the axis of symmetry formula is based on an equation in standard form. It's the only way you can get your A and your B and your C. So we need to find our vertex first and then our axis of symmetry, because remember, the axis of symmetry is x equals the x value of the vertex. So our axis of symmetry is just x equals 3. Okay, from there, the y-intercept, remember the y-intercept is where x is 0. So I'm going to plug 0 in for x and then evaluate. So that would be 0 minus 3 would be negative 3. Negative 3 squared is 9, but you have this negative out here. So you actually get negative 9 plus 1, which would be negative 8. So my y-intercept is negative 8. Okay, domain, that's easy. It's a quadratic, so the domain is always all real numbers. The range is going to be based on our maximum or minimum, so I'm going to find that first. Your a value is still your a value. So in this case, our a value is negative 1, which tells us our parabola is going to go downward, which gives us a maximum. Write my placeholder for my range. So we have a maximum, and the maximum is the y value of the vertex, which I already found, which is 1. And that helps me find my range, because now if that's the maximum, that's the highest y value, then every y's got to be less than or equal to that. So my range is y is less than or equal to 1. Okay, so we took care of all that. Next, we have to find zeros and end behavior. I'm going to do end behavior first. So as x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches. So that doesn't change, that notation stays the same every time. And I've already established that my parabola is going downward, so my arrows are both left and right. Left and right. They're both going down, approaching negative infinity. So f of x would approach negative infinity. And then the last thing I have to do is find my zeros. So the way I do that is I make y 0, just like before. But because this is in vertex form, I don't use the quadratic formula, because again, that's only based on an equation in standard form. So this is going to be just like solving by completing the square. I'm going to take care of everything outside the parentheses, take the square root, and continue to simplify. So I'm going to subtract first, and then you divide to eliminate everything outside of the parentheses of your squared binomial. And then the last thing to do is to take the square root of both sides. And remember, when you take the square root, you have plus minus. And it's the square root of 1. Well, that's a perfect square. So I can just write plus or minus 1 equals x minus 3, because taking the square root of a binomial squared, the square root and the exponent cancel, and you're just left with x minus 3. So to finish, I need to break it apart into x minus 3 equals 1, x minus 3 equals negative 1. And then I solve those two equations. So x equals 4 and x equals 2. So those are my zeros. That's my x-intercepts. And so now I can use all this information to graph my equation for number 5. So I'm going to start by graphing my vertex, which was 3, 1. So over 3 up to 1. And I can also graph my, well, I could graph my y-intercept, says y equals -8. But on this graph they gave me, it only goes to -4. So I can't fit that on there. However, I do have my zeros, my x-intercepts. I can fit those on there. They're at 4 and 2. So I can go to the x-axis and put a point at 4 and 2. And that gives me the 3 points I need to complete my parabola. Those 3 points, the vertex, and a point on each side of the axis of symmetry. And so now I've graphed it based on the information. So that's how you find all those different characteristics of a quadratic function when they give you an equation in vertex form.